So let us see an example of k-fold cross-validation, how to perform k-fold cross-validation to get an idea on the actual final accuracy of the model. So we need a caret package. We need the caret package to perform k-fold cross-validation. We need to choose method CV cross-validation in train control and create an intermediate object called train dat using train control function. So k equal to 10 here, so that's why we need to mention 10. And train date has a lot of details. We might not know all of them. All that we know is this is going to split the training data into 10 parts. To build the model, we will go ahead and build the model, just that the output variable need to be a factor. That is the requirement in caret, so we'll convert that to a factor if it is not already. Then we build a k-fold tree. So when we said we are building a k-fold tree, here k is 10, that means we are building 10 trees. How do we build 10 trees? Instead of giving the data set, we are giving train dat, which is, it will consider this fiber bits data and use this train dat where our information cross validation and number 10 is stored. So this will take care of splitting fiber bits data into many pieces and then finally giving the right accuracy. If you see here, the minimum split size is 10, CP is very low. Obviously we expect higher accuracy for this model, that means overfitted model, but k-fold cross validation should take care of it. We should not get overfitting, we should get the actual accuracy. Earlier when we used something like this, we got the accuracy to be 95%, but it was overfitted. But since this is k-fold cross validation, let us see whether it will automatically take care of it or not. So we are trying to build the k-fold tree. That means we are building 10 trees here. It will take some time because all the trees are really going to be complicated. Now k-fold 10 trees are available. Now what is the final model? So out of these 10 trees, this is the best model. We can draw the tree diagram of the best model. In fact, out of all the models, this is the only best model out of that k-fold cross validation models. So this is the final best model, which looks fairly simple. Now we can find out the predictions and then find out the final confusion matrix and accuracy, and the original accuracy is 75%. With whatever complexity we have mentioned, the accuracy seems to be 75% only. So that is the true final accuracy, that is the true information that is available in the dataset that can be modeled. So that's what we got when we used k as 10. That means 10-fold. That means each piece is 10%. So 90% of the data is used for model building. 10% of the data is used for validating the model. We can even put k equal to 20, which will be like 95% of the data for model building, 5% of the data for testing. So we can go ahead and build k-fold cross validation. We can do the same thing using k equal to 20. So let us see the final model when we put k equal to 20. Here we are going to build 20 models, so this is going to definitely take some time. So this is the final model from the k-fold, that is 20-fold cross validation. We can refresh the graph. This is the new graph, and we can find the new accuracy. This should be near to 75% only. Yes, it is. So that is the overall final 75% is the real accuracy of this model, and that is the real information that is present in the model. Even after building 20 models, we are getting only 75% is the accuracy. Seems like this is the true information that is present in the overall model. One more cross-validation technique, that is called bootstrapping. This is one of the most widely used technique. Once again, bootstrapping has many applications. It can be used for cross-validation also. It is a very unique method, and it definitely gives a good idea on the overall error. It can be used for model building and building very stable models, and it can be, I mean, the results out of bootstrapping can be trusted and accepted very easily. So what exactly is bootstrapping method? So what we do, I mean, bootstrapping, the main usage is it clearly gives a real good estimate of future performance of the model. So whatever is the training data, whatever is the testing data, if we use bootstrap cross validation, the final error that we get out of bootstrap cross validation, that will be the real error of the model, and it will neither be lesser or nor be more. So what exactly is bootstrap algorithm? So we have been doing 10-fold, k-fold cross validation, right? We are taking 90% of the data or 80% of the data, using rest 20% for the validation. In bootstrapping, we take the data in a slightly different manner. We take bootstrap samples. Let us suppose if the training data size is n, let's say if there are 100,000 observations, then we draw a random sample with replacement of size n. We draw 100,000 samples, but how do we do it? We'll do it one at a time. We take a sample point, and we note it down. Again, we put the sample point back in the data set. Again, the data set is 100,000. Again, we take one more sample from it. Like that, we repeat this whole process 10,000 times. Then we have a very new data set, because we have taken it by doing sample with replacement. In that new data set, some observations might repeat twice or thrice, and some observations might not have picked at all, because we are doing the sampling one at a time. But though we have picked the whole 10,000 observations, but some of the points might not have never chosen, or some of the points might have chosen twice or thrice. So that is one bootstrap sample. So one bootstrap sample of size 100,000, whatever is size of the data set. If we do this, 10 such samples or B such samples, then those are called, B bootstrap samples. Then what we can do is, now instead of one training data set, we have 10 or B such training data sets. On each of the training data set, we can build a model, and then we can test the models on the original training data set and get an idea on the overall accuracy of the model. Once again, how bootstrap samples are taken: we have a training data set. We have a training data set of, let's say, 1000. Then what do? We take a sample of 1000 with replacement. That means we take one point and put it here, then, or note it down, and then we put that one point back. Again, we take 1 point sample and then do that 1000 times. That means we take a sample of 1000, but not 1000 at a time. We take one at a time. So in this 1000 observations, there can be some observations which are repeated twice or thrice. There can be some observations which are never picked. Now that is bootstrap sample 1. Again, we do that bootstrap sample 2. Now this data set might be entirely different from this data set, which are again picked from training data only. Again, we do that bootstrap sample 3. So like that we pick B bootstrap samples. On each of them we can build the models. It is a very calculation intensive process, but at least we will, at the end of this, we will get the true training error, true testing error, and the true accuracy of the model that we are building. So once again, so this is the overall a simple example of bootstrap sample. Let us suppose we have a training data of size 500. So what do we do in bootstrap dataset 1? We create a dataset of size 500. How do we do? We increment it one by one. To create that dataset, draw a random point from the training data, note it down, replace it back in the training data, again draw another random sample point, repeat the process for 500 times. This makes a dataset of size 500. This is one dataset of size 500. Call this bootstrap dataset 1. Multiple bootstrap dataset. After doing bootstrap dataset 1, repeat this process again and again, let's say 200 times. Then we have 200 bootstrap datasets, or we can repeat it 10 times. Then we have 10 bootstrap datasets, each of size 500. Then we can build the models on these 200 bootstrap samples or those 10 bootstrap samples, find the average error. Now that gives a very good idea on the overall error. The results coming out of bootstrap sample are very solid and they are very consistent. We can definitely believe the actual accuracy or the error. In fact, we can consider that as the final accuracy of the model. Now let us see how to create bootstrap samples and bootstrap cross validation. It is very similar to k-fold cross validation. So we have to again consider this function, use this function train control. Earlier we gave method equal to cv for cross validation, k-fold cross validation. Here we need to give method equal to boot and the number of bootstrap samples that we want to make. Let us say we want to create 10 bootstrap samples. We know how bootstrap samples are created. Each observation is taken from the training data set. Let's say if the training data set has 1000 observations, and then we will take one at a time 1000 observations with replacement, or 1000 samples with replacement. So that is bootstrap sample 1, and if we take 10 such samples, those are 10 bootstrap samples. So those and all will be taken care in train control. Now we will build bootstrap model. So as an input data set we will give fiber bits data, but we will also force the model or indicate the model to take train DAC, which has the bootstrap information, and we are intentionally giving this whole complexity is very low. We are setting so that we want to grow the tree as big as possible and see whether this bootstrap really works. If this bootstrap really works, then it will build a simpler tree and the accuracy will not be really high on the training data. It will give a decent accuracy on the training data, or whatever is the real accuracy of training data. So bootstrap might take some time because we are building 10 trees here, and once bootstrap is ready, it is building 10 trees, and final model is the best model that is coming out of the bootstrap samples. So this is the tree. Looks like a very, not a very big fancy tree. It has just 7 nodes. Let us see the overall bootstrap predictions and the confusion matrix. Final accuracy. Yes, the accuracy is again 75% only. So it is not really a overfitted model, and anything that is coming out of bootstrap can be taken as real final benchmark. So this is the overall accuracy of the model. In fact, even in 10-fold cross validation we got similar accuracy, and the real accuracy of this whole data set is 75% only. That is the information that is available in this data set, which is again reiterated by using bootstrap sampling cross validation method.